content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight's episode is one that causes a lot of confusion, not just for owners, but even for contractors and inspectors. Building classifications and how they relate to the National Electrical Code. Building classifications are essential for electrical inspectors. Recognizing different building structure types is critical to ensuring compliance with safety standards, which vary significantly based on construction materials, building use, and occupancy hazards. As an electrical inspector, identifying the building structural type should happen before walkthrough even begins. This knowledge ensures that the appropriate wiring methods are applied correctly based on the structure. It is also vital that this information is clearly shown on the approved set of plans or blueprints. A thorough understanding of building classifications is key to selecting proper wiring methods, applying fire safety measures, maintaining structural integrity. Understanding how a building performs during a fire is a cornerstone of life safety. Minimum construction standards are designed to preserve structural integrity long enough for occupants to evacuate or relocate to safety. The combustibility of materials play a major role in how quickly fire spreads, and that directly impacts how we install and inspect electrical systems. The National Fire Protection Association Building Classification 220 defines building construction types based on combustibility, fire-resistant rating, and structural components. Fire-resistant ratings indicates how long material can withstand the fire exposed, measured in hours and determined through the standardized testing. The National Fire Protection Association 101 requires certain occupancies to meet minimum construction standards, typically found in Section XX1 of each occupancy chapter. However, it's important to understand the National Fire Protection Association is not the only authority. Building codes, especially the International Building Code, also defines construction requirements. These requirements are typically based on the number of stories, the occupancy type, the presence of sprinkler systems. Buildings are categorized into types 1 through 5, and when specified, includes fire-resistant ratings for structural elements. Here's the key takeaway right up front. The National Electrical Code does not classify buildings the way building codes do. Instead, the National Electrical Code relies on classifications defined by other codes. So tonight, we will break down what building classifications are, where they come from, how they impact electrical installations, and why misunderstanding them leads to failed inspections and unsafe systems. What are building classifications? Building classifications come primarily from building codes and fall into two major categories. The first one is the occupancy classification, how the building is used. Examples include residential, commercial, industrial, assembly, and healthcare. Number two, the construction type, how the building is built. This includes the fire-resistant, the structural materials, and the combustibility. Examples include type 1, fire-resistant, type 2, non-combustible, type 3, ordinary, type 4, heavy timber, and type 5, wood frame. Again, the National Electrical Code does not define these, but it absolutely responds to them. Why the NEC cares? The National Electrical Code is focused on electrical safety, but building classification directly affects fire risk. A wooden frame home behaves very differently than a steel framed hospital. Number 2, the occupancy safety. Hospitals, schools, and assembly spaces require higher protection levels. Number 3, the system reliability. Some systems must remain operational during emergencies. The occupancy types, the National Electrical Code that impact residential and two-family dwellings. So the key NEC requirements would include arc fault protection, GFCI protection, and load calculation dedicated circuits. In a commercial building, considerations are load diversity, lighting systems, and emergency power systems. In industrial occupancies, considerations include motor controls, Article 430, heavy equipment loads, and hazardous conditions. Assembly occupancies include emergency lighting, exit signage, and panic safe systems. In healthcare facilities, Article 517, redundant power systems, life safety branches, and isolated grounding. These are life-critical systems, and they are not optional. So special occupancies, like the hazardous classified locations, Article 500, examples are gas stations, chemical plants, grain silos. The classifications are Class 1, gas and vapors. Class 2, dust. Class 3, fibers. One spark can cause an explosion. So the requirements in these locations are explosion-proof equipment and sealed conduit systems. The construction type directly affects the wiring methods, the cable types, and penetrations. This is important to remember. You cannot compromise fire-rated assemblies. If you penetrate a fire-rated wall, you must maintain the rating. Use approved fire-stopping systems. Now, let's bring this into a real-world situation where I see these problems often. I'll give examples of a couple of inspections. A recent project involving the renovation of a commercial office space revealed a significant issue regarding code compliance. The contractor reused existing non-metallic sheath cable operating under the assumption that it would be considered grandfathered due to its prior use. However, the building type non-combustible construction did not permit the use of NM cable because of the strict fire safety and structural regulations. As a consequence, the project experienced the following outcomes. The inspection immediately failed, causing delays. The requirements were to remove the existing wiring and reinstall the wiring methods with conduits or armored cable or MC cable. This situation underscores the importance of strictly adhering to the current building codes and regulations, particularly concerning electrical installations in commercial properties. So the lesson here, identifying the construction type before the installation is critical. It is important to never assume that existing wiring methods are code compliant. Ensuring compliance from the start can prevent future delays and ensure safety in the installation process. Another situation, fire-rated walls. The violation. The electrician drilled through a rated corridor wall in a hotel. The penetration from the guest room through the corridor to run a branch circuit. They did not install any fire-stopping systems. So the code issue here is the fire-rated assembly must maintain their ratings even after penetration. The outcome, the inspection failed, the building inspector got involved and required an engineered fire-stopping system. And I see this more than you would think. Lesson: you are not just running wire, you're penetrating a life safety system. Another example would include a local college use standard electrical equipment such as 1900 boxes and standard lighting outlets and devices installed in an area storing highly flammable liquids. The problem: this area should have been classified as Class 1 hazardous location. The code issue requires explosion-proof equipment and sealed raceways were not installed. The outcome: it was an immediate red flag, and there are serious safety concerns. So full replacement of the electrical equipment and raceways were required. The lesson here: one misclassification can turn an electrical system into an ignition source. Summarizing these common mistakes: treating commercial like residential, common mistake; ignoring hazardous classification; improper installation in fire-rated assemblies; and missing emergency systems. So why does all of this matter? Number one, the wrong classification equals the wrong installation. Number two, impacts life safety, especially in hospitals, schools, and high occupancy buildings. Number three, it affects liability. If something fails, the electrical contractors are responsible. The electrical inspector's responsibility includes verifying the building structural type to ensure integrity. For fire safety, fire-rated penetrations properly sealed, fire-stopping systems correctly installed, and wiring methods, conduit systems in non-combustible construction areas, NM cable properly installed in wood frame buildings. So the practical takeaways here is: before starting any job, identify the occupancy classification, identify the construction type, review the approved plans, coordinate with the authority having jurisdiction, and never assume, always verify. Building classifications is not just a technical detail, it is the foundation of electrical safety and compliance. If you misunderstand the building, you will misunderstand the National Electrical Code. And that leads to failed inspections, unsafe installations, and real-world risks. Electrical work is complex. Whether you're installing new systems or modifying existing systems, understanding the structure you're working on is critical. This podcast exists to help you understand and stay informed, stay compliant, and stay safe. Thank you for your continual support and engagement. Your questions help strengthen this professional community and improve safety across our industry. Join me Wednesday, April the 22nd for the next episode. In the meantime, visit my YouTube channel for short videos highlighting common inspection mistakes and best practices. You can reach me on Facebook, Instagram, YouTube under Ask the Lady Electrical Inspector. Also, you can email me questions and concerns and topic ideas. Ask the Lady Electrical Inspector at gmail.com. Let's continue working together to maintain safe and compliant electrical systems. Until next time, stay safe, stay compliant, and keep learning. Good night.